So here's what my little picture looks like. So clearly I'm not an art teacher. So here's the rock jumping from the crane to the other building. So I just wrote down that he ran and then he jumped. But when you jump, obviously you jump up first. And then as he moves over, he also falls. So my red line here is him jumping, and then gravity is going to pull him down. You could have written down something like it's going to be a curved shape, it's going to look like, and then described the shape. That's fine. You could have used more of your mathematical vocabulary, but I don't want to talk about that right now. I do want to talk about that in the notes themselves. So this is a little meme I had found, and this is the skyscraper poster. And there's 3 scenarios here. The red one is assuming he jumped first. He's not going to make it to the window. The green one is saying that he's going to run forward and somehow didn't lose momentum. And then the yellow line is from a short squat thrust. So obviously in this scenario, movie magic has taken place, because by the laws of physics, he never would have actually made it into the other building. I just thought that this was pretty interesting, math in real life. So getting back to the notes, the shape is a parabola, and we get that shape from a quadratic function. So today we're going to talk about quadratic functions. And you learned about these in Integrated 2. And in Integrated 2, you should have learned that the standard form of a quadratic function is y equals ax squared plus bx plus c. Quadratics were a big focus in Integrated 2, so this is something that you should know and sort of be familiar to you. For a quadratic function, there's 2 scenarios. One can be shaped up like a cup, and the other can be shaped down like a frown. And here's some vocabulary that you learned in Integrated 2 that I'm going to write down for future reference. The direction of the curve is known as concavity. And a parabola is just what they call the name of that curve. What causes the concavity? If there's a positive a value out front, so if this first number is positive, then it's going to be concave up. If that first a value is negative, then the graph will be concave down. Going off of that, you should know about a vertex, and I have those marked here. The vertex is where the parabola changes direction. We have referred to it as a turning point in the previous set of notes. If the parabola is shaped up like a cup, then that vertex value is a minimum. And if the graph is shaped down like a frown, then that is a maximum value. It's the highest point if your graph is curved down, and the lowest point if your graph is curved up. So make sure you have all of these notes copied down. And that's just what my notes look like. The next thing I need you to do is underneath that, sketch yourself a set of x and y axes and put a small parabola on there. It doesn't have to be perfect. I just want you to have a visual. So with that picture, we're going to talk about positive or negative intervals. So here is one of the vocabulary words. It's a definition in red that goes with our goal. So positive/negative intervals are the x values where the function, or f of x, is positive or negative. So these are pretty simple to find. All you do is you look on the graph for where the function, or the graph itself, is in a positive y value or in a negative y value. So over here on the left-hand side, right here is positive. Then we go below the x-axis. So this part of the curve or the parabola is negative. Once we cross over again, that's still negative. So this whole bottom part right here is negative because the y value is negative. And then once we cross back over the x-axis, it becomes positive again. And here there's the word interval in the definition. And just like on the first set of notes where we had increasing, decreasing intervals, we will end up using interval notation. So make sure you have these notes written down as well. So showing you again, here's what my notebook looks like. And then draw yourself this example. It doesn't have to be perfect. You do need to make sure that you include the key points of -2, 0, 2, -3, and 5, 0. So the first thing I do for positive and negative intervals, just like increasing, decreasing, is you're always going to start from the left. So let's talk about your positive intervals first. On the left-hand side, there's an arrow, so it's coming from -infinity, and it's going to stop being positive at -2. So you might want to label that with a P. So it's positive right here in this section. But then once we hit the x-axis, it becomes negative. So down here, all of this is going to be a negative interval. And then we cross over the x-axis again, and this would be a positive interval. We're using interval notation. So when we're using interval notation, we're looking at the x value. So this, like I just said, this is coming from -infinity. And then this x value is -2 with your square bracket like you see here. Then this is negative underneath, and then it starts being positive. Starts being positive again right here at the x value of 5. So finishing this second positive interval, it comes back positive at 5 and continues being positive all the way to positive infinity. So in this case, in this example, we have 2 positive intervals. In another graph, there might be 3 or 4. It just depends on what the graph looks like. So taking a look at the negative intervals, at the negative interval, it's going to be the opposite of where it's positive. So like I said, here and here, it was positive up here and positive up here. So the negative is going to be this spot in between. And you just use the x values. This x value on the right is -2. And the x value on the right would be 5. Both with square brackets. So make sure your notes look like that, please.